Alright, hello 8th grade. So today we are looking at a few more solving systems of equations by graphing. So we didn't quite get through these yesterday, so we're looking at a couple of the same ones from yesterday and a couple of things that we didn't quite get to talking about. So first of all, quick recap. If we're graphing things that are already in slope-intercept form, we don't have to maneuver these around at all. We don't need to find our x-intercept, y-intercept, anything like that. We can just graph these. So friendly reminder that if we're graphing these, we're starting with our y-intercept. So we're starting off with our second thing here. So this is our y-intercept. So this one we're starting at -5. So 1, 2, 3, 4, 5. Should draw my line a bit further. Oops. There we go. And then if we don't have a number out front for our slope, that number is going to be 1. So we're going up 1, over 1, up 1, over 1. So rise over 1. If there's not a number there, it's automatically a 1. So that's our first line. And we're doing the same sort of thing with our second line. So same sort of thing, we're starting at our y-intercept, which in this case happens to be 3. So 1, 2, 3. Hopefully you can see the green. You can see the green pretty well. Okay, so if we're looking at that, we've got a point at 3, and again, if we don't have a number there, it's automatically a 1. And if there's not a number on the bottom, it's a 1. So 1s are nice. Just watch out for this one is a -1. So instead of going up 1, we're going down 1, and then again to the right 1. So even though we're going down, we're going to the right, because that number on the bottom is still a +1, and positive x's are this way. So there's our second line. And as soon as we've hit this point, you can stop, but if you keep going another 1 or 2 in this direction, that's fine. And again, we're looking for where our points are crossing. So we're looking for a coordinate point here, and this one happens to be at 1, 2, 3, 4, and then down 1. So 4, and then -1. So we're looking for a point. Okay, and quick refresher on ones that aren't in slope-intercept form. So we got something like this. Plane there. That first one, we're probably going to want to find our x and our y-intercept. So if we're finding our x-intercept, then that means that y equals 0, because again, our x-intercept is when we're along our x-axis, and these points are all something 0. I'm going to fix that real quick. So if we're looking for our x-intercept, that means we're plugging in 0 for y. So we still got this x here, and plus, and then instead of this y, we're going to have a 0 equals 4. But x plus 0 is just x, so this is just x equals 4. So this is just a point on our x-axis at 4. And then we're going to do the same thing with our y. So if we want our y-intercept, instead of y equals 0, we're going to say x equals 0. And we're going to plug that on in here. So 0 plus y is going to equal 4. But 0 plus y is just y, so y equals 4. So that's a point over here on our y-axis at y equals 4. So again, watch out for those aren't one point. Those are two separate points. So this isn't a point at 4, 4. This is your x-intercept at 4. This is your y-intercept at 4. So if it helps, maybe rewrite those as like actual points. So those are two separate points that we're finding there. And then we're drawing a line that goes through them. Now, this other thing is one of the ones that we didn't get a chance to talk about yesterday. So if we don't have an x there, if we just have a y, I'm going to add a plus a 0x on the end there. Or if you want to shuffle that around so it looks more like slope-intercept form, we could say that's a 0x plus 3. Now, the reason we can do that is 0 times anything is 0, even if that something is x. So 0x is really just 0. So this is really just saying 0 plus 3. Which is a little bit redundant, but it's going to help us as far as our line goes. So this is a y-intercept at 3. And then if our slope is 0, same sort of thing as that 1. If there's not a number on the bottom there, that's a 1. So we're going to rise 0, or not rise at all, and then run 1. So rise 0, run 1. So this is just going to give you a horizontal line at 3. Now that we know that that's what that sort of thing is going to give us, if you want to jot down if we have y equals a number instead of just an x, that's going to give you a horizontal line, Now that's a thing that we know how to do. So you don't have to go through every single time and do this. If I have like y equals 2, I can just draw a line at 2. You don't have to go through and do this every single time. Now that this is a thing that we know, this is going to give us a horizontal line. And again, we're looking for where our lines are crossing. And these are crossing at 1, 3. So again, we're looking for that point there. We're looking for the point where our lines cross. Okay. Now, again, a couple weird things that could happen here. The first weird thing is coming from if we have something like this. And I'm actually going to start with my second line here because this one's already in slope-intercept form. So I'm going to graph that one first. I'm just going to say this is our red line, just so we know that that's that color, because we're doing it first. So if we're starting at 1, that's our y-intercept. So our y-intercept is at 1. And then if our slope is negative 2, that means we're going down 2. And again, if there's not a number on the bottom, it's automatically a 1. So anytime we've got just a number as our slope, the number on the bottom has to be a 1. So we're going down 2 and then over 1. Down 2, over 1. So we got that line there. Sound effects are definitely necessary. And then this one up here, we're going to go ahead and find our x-intercept, find our y-intercept, because that's not in slope-intercept form. Now, eventually, once we get to algebra next year, we're going to talk about some ways to shuffle that around so that we don't have to find our x-intercept, y-intercept every single time. But for now, we're going to stick with this. So if we're looking for our x-intercept, then that means that y equals 0. So we've got a 2x plus that y is 0 now equals that negative 4. But plus 0 is not really doing anything, so that can just go away. And then if we're dividing by 2, negative 4 divided by negative 2 gets you negative 2. So again, that's a point at negative 2 on our x-axis. So that's this point over here. So if it helps, maybe rewrite that as negative 2 is 0. And then we're going to do the same thing to find our y-intercept. So if we're looking for our y-intercept, then x is going to equal 0. So we got a 2 times 0 over here, plus this y equals a negative 4. 2 times 0 is just 0. 0 plus y is y. So this is just y equals negative 4. And again, that's a point at 0, negative 4. Because the 0 is what we plugged in for x in order to get that y. So now I got a point at 0, negative 4. Negative 1, 2, 3, 4. Didn't draw it long enough again. Oh, hey, what's going on with those? She has blank screen. Okay. So if we got parallel lines that aren't going to cross and we're looking for where they're crossing, again, if we're looking for where our lines are crossing and they're not, that's no solution. So that's one of these things. And feel free to make a happy Saturn out of it. Okay. The other thing that could happen, so we got one solution, we got no solutions. The other thing that could happen is if we got something like this. So if we're graphing one of these, if we got parentheses, what do we want to do with that? Hopefully you said we want to distribute that. So we're going to distribute that 3 there. So we got y equals 3 times 2 is 6. Minus 3 times 1 is 1. Or, sorry, 3 times 1 is 3. 3 times 1 is not 1 is p. It is way too late at night right now. Okay, so now we're going to graph that. That's already in slope-intercept form. So we're starting at our y-intercept, and watch out for that's a negative 3 there. So that's a negative 3 on our y-axis. And then we're rising 6. And again, if there's not a number on the bottom there, it's 1. So we're going up 1, 2, 3, 4, 5, 6, and over 1. And we're drawing a line through those. So there's that first line. Now, if we're looking for that second line, we're looking for our x-intercept. We're looking for our y-intercept. If we're looking for our x-intercept, that means that y equals 0. So y is 0 plus 3 equals 6x. 0 plus 3 is 3. And then if we want to get rid of that 6, we're dividing. And when you're dividing, watch out for which way you're dividing. So watch out for this is 3 divided by 6, not 6 divided by 3. So we're taking 3 divided by 6, which gives you 0.5 or 1/2, depending on whether you like fractions or decimals. So that's a point on our x-axis at either 1/2 or 0.5, comma 0. Okay, let's find our y-intercept. So if we're looking for our y-intercept, that means that x equals 0. So we got y plus 3 over here equals 6 times 0. The 6 times 0 is just 0. And then we're subtracting a 3 to get rid of adding 3. 0 minus 3 is negative 3. 1, 2, 3. Oh, hey, they're the same line. And if they're the same line, again, that means that any point on our line is a solution. So that's the solution, that's a solution, that's a solution. So we are calling that infinite solution. So an infinite number of solutions there. So those are the 3 things that can happen if we have 2 lines. So either they're crossing and we have 1 point, they're parallel and we have no solution, or they're the same line and we have an infinite number of solutions. Which is why the last thing we're doing with this, and if you're looking at number 8 and 9 on the homework, that's what's going on here. So please don't actually find like the point where they're crossing, because some of these aren't crossing at nice points. So when a line passes through each pair of points, and we want to determine if the system has no solution, 1 solution, or an infinite number of solutions. So we're not necessarily looking for what that solution is, we're just looking for, is it 1, is it none, or is it an infinite number? So these ones are nice because we can just graph those points and draw lines through them. Just watch out for which pairs of points you're drawing a line through. So I'm going to make these ones green, and I'm going to make these ones red, just so that we can tell which is which. So if we're looking at those green ones there, we got a point at 1, 3, and we got a point at 4, 7. 1, 2, 3, 4, 5, 6, 7. And we're going to draw a line through those. And we're going to point at 2, 6, 2, up 6. And we're going to point at 0, 8. And we're going to draw a line through those. Okay, and again, all we're looking for here is there 1 solution, are there no solutions, or are there an infinite number of solutions? And if they're crossing, we've got 1 solution. Now, it's not always going to be a nice number, and this is why we're going to eventually get into some ways of solving these that aren't graphing. Because if we're just looking at that graph, it's not really easy to tell exactly where that point is. I mean, it's 2 point something and then 5 point something, but we don't know exactly where that is. So that's kind of the limits of solving these by graphing, is if it's not a nice point that's nicely on a line, it can be kind of hard to tell where that is. So that's why we're eventually going to get into solving these a way that's not graphing. So let's be a bit more specific with points like that. Okay, let's do one more of these. So again, I'm going to make these ones red. I'm going to make these ones, I'm going to go blue this time. Hopefully you can see the blue on there. So we got -2, -2. We've got 0, 2. And we're drawing a line through those two. So we're drawing a line like that. And then we're drawing a line through the blue one. So we got one at 1, 1. We've got one at 0, -1. Ooh, hey, what's going on with these? Hopefully it said they're parallel to this piece, so there's no solution. So if we have something like this where our slopes are the same, so even though like this is up 4 and over 2, and this is up 2 and over 1, 4 over 2 reduces to 2 over 1. So that's another way to check and see if they're exactly parallel, if you didn't like maybe draw your lines exactly straight. So if you're not 100% confident in your like straight line drawing abilities, you want to make sure they're parallel. That's another thing you can do, is you can check your slopes and see, do they reduce to the same thing. So these both reduce to 2, which means our slopes are the same, so they're parallel. Yay! Which means we have no solution. Happy sad. Okay, so that's it for solving systems of equations by graphing. Hopefully we got a slightly better handle on that now. The homework numbers are in the description. They're also up in Google Classroom. I believe they posted yesterday. So go ahead and give that a try. And once you're done with that, instead of like waiting to hand it back to me whenever we're back in school again, go ahead and just either take a screenshot of that, take a picture of that, and send me an email with that in it so that I can get those graded and back to you. And I will see you next week.